Welcome. My name is Luca De Loca, evangelist at Veeam Software. Veeam Cloud Connect offers complete encryption for data at rest thanks to Veeam backup and replication encryption capabilities, but also for data in flight, so that any information exchange between an end user and the service provider is protected while traveling over an unsecure channel like the internet. Security-savvy people would probably like to know more details about how network encryption is implemented in Veeam Cloud Connect. This video is going to give you all the details. Veeam Cloud Connect uses two different encryption technologies: SSL, or Secure Socket Layer, and ACE, Advanced Encryption Standard. SSL is a generic term related to a family of communication encryption technologies. In more details, Veeam Cloud Connect uses the latest TLS protocol, which stands for Transport Layer Security, and it never fails back to oldest and unsecure version of SSL. Together with SSL, also ACE is used. It's a symmetric encryption algorithm and the de facto standard for advanced data encryption. Let's see how Veeam Cloud Connect uses both for different purposes. During the initial connection between a customer and the service provider, the communication channel over a single TCP port, 6180 by default, is protected with SSL. By verifying the SSL certificate published by the service provider and comparing it to the host name the provider is using for publishing Veeam Cloud Connect itself, a customer is assured that he is effectively connecting to the chosen service provider. Providers can also create and send to customer the fingerprint of their own SSL certificate for additional security. SSL is an asymmetric encryption algorithm. There is a private key safely stored at the service provider and a public key published over the internet and retrieved by users. This technology is well suited for protecting communications over unsecure channels like the internet, especially for the initial handshake, but at the same time is not suitable to exchange large amounts of data. Being an asymmetric algorithm, performance during decryption are far worse than during the encryption. Also, it guarantees the authenticity of the server publishing the key, in this case the Cloud Connect environment, but not the user sending data to it. For this reason, while all control and communication commands use the SSL TLS tunnel, the exchange of data between a customer and a service provider, for example during a backup operation, uses the other Veeam backup and replication encryption based on ACE 256. One of the security issues of using a symmetric key over an unsecure channel like the internet is the fact that anyone who holds a copy of the key can decrypt the cipher data. So it's paramount to implement a secure mechanism to safely exchange the ACE keys between the customer and the service provider. Let's see how this happens in Veeam Cloud Connect. There are two Veeam backup and replication installations involved in Cloud Connect. One at the service provider, publishing the service, and one at the customer side, consuming the service. Every activity is initiated by the customer side. When a new operation towards Cloud Connect needs to be started, the customer side sends a control command over the SSL tunnel. The Cloud Connect installation at the service provider responds to this start command and it creates the encryption key A. This key uses ACE 256. Using the SSL protected tunnel, key A is passed to the job manager of the customer in a secure way and to the target data mover at the service provider directly via a local network communication. The customer job manager then creates his own encryption key, key B, to be used for encrypting traffic between the customer and the service provider data movers. A new tunnel is initiated by the customer job manager using key A. Thanks to this, only the service provider side is able to decrypt data coming from the customer side. Using this tunnel, key B is delivered in a secure way to the data mover at the service provider side. At the same time, key B is also delivered locally to customer data mover using the local network. From here on, data transfer of the backup job payload is encrypted using key B. In this way, data is encrypted in flight by an encryption key that is created by the customer and not by the service provider. Thanks to the use of key B, customer data are safely sent to the service provider. Any attempt to intercept and modify the encrypted traffic raises a security warning, as the key is only owned by the user and his service provider. This guarantees to customer the avoidance of possible man-in-the-middle attacks. When additional data transfers needs to be done during a new session between the customer and the service provider, the entire process is repeated from the beginning, and new keys A and B are generated again. Finally, when WAN acceleration is used, the process is exactly the same, and key B is also passed to both WAN accelerators at source and target locations. In this way, WAN acceleration is able to decrypt on-the-fly data blocks encrypted by the user. This solution allows the protection of Cloud Connect users' communication, and it's leveraged regardless the user is also encrypting his backup files. For backup file encryption, in fact, an additional set of ACE keys is created to encrypt the backup file themselves. Those keys are not related to the communication keys. If you want to learn more about Veeam Cloud Connect, visit our website at veeam.com. Thanks for watching.